Well, hi, and thanks for joining me in my shop. It's been a few days since I've been in here over the long weekend, and we're going to get back to working on this guy here. And what we're focused on is the eye tube, the magic eye, and why a couple things are happening. One is it's dull. It's not very bright. Secondly, it doesn't seem to respond very well, or it doesn't seem to be receiving the signal it needs to respond well. And I have a replacement one, which doesn't seem to work any better. In fact, it seems to work worse when I put it in. So, and I've done a few things now. I've checked the B plus voltage. It's quite low, around, it would have been around 100, and then I rewired the set to connect the magic eye to a higher voltage point in the B plus supply, and that seemed to help a bit. The tube is glowing, although very, very faint. So what to do next? And I've got quite a number of ideas and suggestions here. So I think one of them is raise the B plus. I learned that in this radio, the detector tube is this one here. I'm sorry, the rectifier tube, 25Z5 tube, actually doesn't work. The heaters work, but the tube itself does not work. And someone has compensated by putting a diode, a regular solid-state diode underneath the tube to take the place of the rectification that the tube would normally do. The tube is in a half-wave rectification approach, I guess I could say, and rather than a full wave, it's a half wave, so one diode does the same thing. But that may have resulted in a lower than expected B plus voltage. There is a resistor in series with the diode. If I remember right, it was 270 ohms. That resistor may be dropping too much current. Now, another thing that had been done to the set is the speaker's been replaced. So if we take a look here at the cabinet, that speaker in there is not the original. The original speaker had a field coil on it. Field coil plays an important role in the power supply filtering system. And with a field coil working as a choke coil, you can have small capacitors in the power supply and still manage to filter it quite nicely, filter out the hum quite nicely. Take away the field coil when you take away the speaker, and now you've got something here that's, if you just kind of, well, what would I say, take out the field coil and just short the lead wires together, the radio's going to hum like a crazy thing. So some previous repair, knowing all this, replace the field coil with a resistor, 1500 ohm resistor, and then up the size of the capacitors in the power supply, up them a lot. Raised one to 100 microfarads, and the other one he left as 40. And in fact, the 100 had another 40 in parallel with it, although I'll bet you the 40 was old and it probably wasn't producing 40 microfarads. But it was, you know, all told, that's a lot of capacity in the power supply filter. The problem with doing that is on startup of the radio. If you're not careful, you start the radio up, those capacitors will look like short circuits more or less, and for a very short period draw a lot of current, easily too much for some of the components involved, too much for a vacuum tube rectifier, and too much for a diode potentially too. The diode that's in there is good for about 1 amp, I think. So in order to protect the diode, because the tube doesn't work, it doesn't really matter, whoever did this put a resistor in series with it, so when you turn the set on, the resistor takes the initial, how can I put it? It will restrict the inrush of current, that's the proper way to say it, and protect the diode. But then after the charge-up period is done, which only takes a fraction of a second or a second or so, that resistor is still sitting there. And now it actually presents a problem, because it will drop voltage that could otherwise be utilized in the radio. You just leave it across this resistor in the power supply. So that's what you got to kind of play with is, gee, if I reduce the resistor, I may blow up the diode on charge up when you turn the set on. On the other hand, a resistor too big, I've got enough voltage here to run the radio part, but not to run the eye. So, not sure what to do about that. Now, another interesting question or concern was raised is on the schematic I've been studying, it doesn't really show this magic eye being connected. It does kind of. It has just a line on it. Where is that schematic? Now, it's not with me at the moment, but I'll get it in a little bit. But it shows only one line on the schematic pointing to, it says, to the grid of the magic eye. The rest of the wiring is not included. So there's a good chance I'm looking at a schematic for a slightly different model of this radio. But if not, then that suggests that this radio is, it's a little hard for me to believe this. It could be that this heater is now in series with all the rest. The radio was really only designed for the rest. And with this one in there, in the heater string, it's reduced the heater voltage supply to all the tubes. Is that really the case? I'm not so sure. Because this looks like a factory installation to me, for sure. This doesn't look like somebody whipped this in later. In fact, it's ridiculous to think that, since the faceplate has a hole in it and everything. I mean, it's clearly came out of the factory this way. So it's probably more likely I haven't quite got the right schematic for the radio. It was a bit of a concern if I'm going to be troubleshooting and I don't have quite the right schematic. It's very, very close. I don't think there's any doubt about that. But this is a slightly different model from the schematic I've got. So that's another interesting concern. Just what is the heater voltages on these tubes, and in particular the eye tube. They look fine to me, but and the radio does work on a radio basis. So there's that. Now another one is, if you are going to operate these tubes, which are normally looking for at least 125 volts, and we're right near there, about 120 on it or 115 on it. That this resistor that's in the back here, this resistor that you can see sticking out here, and then this particular one I actually put in to replace the one that was in there. This resistor is a megohm. That's a typical size. That's a recommended size for a resistor in this kind of magic eye arrangement. Under low voltage conditions, you can drop this to half as much, 500,000, and that'll help the eye operate. I guess it'll brighten it up. So we have that option. So there's all that about the voltages on the tube and getting its operating condition right. Now the next question is, the AVC voltage that the tube appears to be connected to doesn't vary very much. It only goes from, I think, a low of -1 to a high, or an even lower voltage, if you like, of -5. And I can get -5 by ramming a pretty heavy signal into it from my signal generator. So it looks like the AVC voltage is weak, is not varying as much as expected, or, since some work has been done under the set, the grid wire from the magic eye has been connected to the wrong point in the radio, and there's a better point somewhere to connect that magic eye. That's what I suspect is really the case. So we're going to look into that and try to check a few potential locations to connect the magic eye. I'm pretty sure the grid connection to the magic eye is a very, very, very high impedance, so it wouldn't matter too much just where you connect it, anywhere in the radio. It's an interesting notion, come to think of it. I wonder if you could use the magic eye as a testing feature by taking off the grid wire and popping it around the radio as you wish, just to check things. I wouldn't recommend it, but it's an interesting idea to think about. So those are the issues here. Which one should we go at first? I think it might be interesting to examine the B plus question and the resistor that's in series with the diode. In fact, let's take a look at it here. Let's just see what it is. And I may have written it down when I was mapping out the mapping things out. So there's the resistor, 270 ohm resistor. It's right there. Looks like a 1 watt carbon resistor. And I suppose we could operate the set and we could read the voltage across it and see how much is dropping. But kind of the real question is, how small do you want to make that before you risk blowing the diode on charge up? Now I've changed the filter capacitors. The 100 is gone and the old 40 double 40 is gone, and I put two 50 microfarad capacitors in. So capacitance a little less. So that in itself, maybe we could reduce this. But I really want to get some better idea of what this should be. It might be as easy as just saying, well, for a short while when you first turn the set on, the whole voltage goes across this resistor. So if we can figure out what that voltage is, we know the resistance, we can figure out the current flow, and then we can make a few sensible decisions around shrinking this resistor. And I guess another question is, how much benefit can you really get? I mean, if I cut it in half, how much benefit would I get there? If there's a total of 100 and let's say 40 volts available, and this thing's dropping 30 of it, if I cut this in half, will I then only drop 15 here? Or will it just change the nature of the operation of the radio enough that you're still dropping significant voltage here? So I don't know these things. I have to do a little bit of research on that first. And that's what we're going to be doing in this video. Is not the research. We're going to be doing the experiments. But I did want to go over for a couple of reasons. One is make it clear to you, but also make it clear to me what it is I'm going to try to do on this thing. So I think I'm going to look into this resistor a little bit before I make any real changes here. Okay, after just a little bit of research and discussion, man, the internet is a wonderful thing. I don't think I need to tell you that. The impression I'm left with is perhaps the 270 ohm resistor in here is bigger than is necessary to protect the diode. And so it could be reduced. Some examples I saw, although they may not relate to this particular power supply and circuit, was a 50 ohm resistor as opposed to 270. So once the inrush current phenomenon has passed, the size of this resistor could be reduced. Well, it could be reduced right down to nothing, and that would raise the B plus up, perhaps raising it above the design of the radio. So here's a closer look at the resistor I'm talking about. So what I've decided to do here is fire up the set, which means plug it in and turn it on. I don't really want to catch it on fire. And measure the B plus voltage, and then stick a resistor across this with the set operating in parallel to reduce this voltage to about half what it is now. So I need another 270 ohm resistor. Drop the voltage, or drop the resistor down, and we'll see how high the voltage goes and see what happens to the magic eye. And if it's a big thumbs up on that, then I will put that second resistor in permanently, or replace this one with a smaller one, and voila, problem gone. If I blow the diode in the process, no problem, I got lots of diodes here to replace it with. Another alternative here is just to put a bigger and bigger diode in there. Apparently, diodes cost next to nothing too. So that's probably a 4000 series diode in there. In fact, maybe we'll take a closer look at it and see if we can figure out what it actually is. We can read it here, and it's good for about an amp. I see a number on it, but yeah. But anyway, I think that's probably the best approach we can take. So let's see. I'm gonna have to plug in the speaker here, or do I? Nah, I don't need the speaker plugged in for this. We'll keep the volume low, and we should be okay on that. Okay, so let's get everything set up here. supply's off, we're plugged in, and let me get my voltmeter out, get it ready to go. You know what, maybe I'll use the indicating meter here. I actually prefer indicating meters, old style meters, to digital meters, except in the case of precision measurements. Precision measurements, yeah, you can't beat the modern digital meter, but in terms of just human communication, I really like watching the pointers go up and down. Yeah, it doesn't take much to thrill me, does it? So we'll get that set up. That's my hot chassis warning light going on there, just in case. Which is why you use it. You use it just in case. And now, hey, I'm going to need a 270 ohm resistor. Let's hunt one of those down here. Okay, so I've got the resistor ID now. This is actually 250 ohms, but that's close enough for this. And I'm just going to set up some clip leads here because I just want to do this temporarily. And should be able to find out what we need to know. Now I got another whole approach to finding out what voltage, or what voltages, or how voltages, how the B plus voltage affects the I by using an alternate power source and control it, which I can control separate from the radio. And I could actually crank the B plus voltage up and down on the tube and make an observation as to what is happening. So the other clip lead goes here. I want to be kind of careful with these clip leads, considering what part of the circuit they're being connected to. Okay, and I'm going to hook up the B plus meter with clip leads too, rather than poke around, at least at first. So it all kind of goes automatically here. And we want to watch the voltage rate at this point here, which is the higher voltage part of the power supply. Okay. The resistor I will connect between these two clip leads, but I won't actually connect it. I'll just have it ready for connection, so we can do that. Good. I think everything is set to go. Quick little safety check. Don't have the speaker plugged in. Shouldn't matter. And we're ready to go here. So we're going to start it up with voltage restriction. So I thought the light bulbs are, well, you can see, yeah, they're right out of view. They're back here. You can't see them, but I can certainly see them. So, volume down, switch on, tubes in. It's been 4 days since I've been in here, so I just want to be absolutely sure what I'm doing. Here we go. Should have kept my eye on that meter, shouldn't I? Shame upon me. So that's a 150 volt scale, and we're kicking in around 130. And now as the currents begin to flow in the tubes, you can see the voltage being pulled down. It's actually falling across that resistor. So, you know, if it went up to, what was it, 135 or so, and now it's down to 110, so there's 25 volts being lost on that. Yeah, it's going back up. Why would it go up a little bit? Okay, now we're ready to do a couple things. I will use my digital meter. We'll take a look at the actual voltage drop on that resistor. just on a counter. I think it's 25, but let's see what it really is. Well, and it's right at the end of these clip leads, isn't it? 3.2, what? What happened there? Jeez. 3.2? Well, how come? Wait a minute. Wait a minute. Now I still have current restriction on the line voltage coming into this radio, so it's running somewhere around, again, around 90 volts or so, instead of the 120 I could give it. So let's read directly across that resistor. Try not to get my arms in the way here. That's more like, whoa! That wasn't quite the right reading. Let me try that again. Can you see it there? A 3.2. Wow, that's nothing. Well, once again, results unexpected. Let's give the radio full voltage here. Watch this meter go here. Yeehaw! 140. 130. Wow, this is a lot higher than I thought. Somehow I thought the voltage was more like 8. You know what? Maybe this meter's not accurate. Let's read it with this. $130. It's right on. So there should be 130 volts on the eye tube. Maybe that eye tube's just glowing beautifully up there. This is the resistor on the back of the eye tube. Minus 5 volts. When I say back of the eye tube, what I really mean is one leg of the resistor that's in the eye tube. Wow, these are all... Yeah, I make that sound when I don't know what to say. Let's pull some clip leads off this here. I'm going to shut the power off for a moment. Pull out the clip leads. Got a totally different result here from what I expected. I shouldn't say totally different. I should say quantitatively different result from what I expected. I even have some conflicting readings because we saw the voltage fall back, and my assumption is that fallback after startup is the voltage drop raising on the resistor up here. So it should have been across the resistor. So what I saw, 30 volts disappear. I would have thought that was across the resistor. Okay, so now we have our eye on the magic eye. And let's just see if we can get a little better focus on here. Okay, it looks like it's going to want to focus on the back. Let's get it that way. So let's switch it back on and we'll look at what the eye is doing. I've left one clip lead into the circuit here. left this green one in. I don't think I want any of them in here anymore, since the paralleling the resistor idea has gone out the window at the moment. Ah, the best laid plans, eh? What do they say? Military plans fall apart with first contact with the enemy. Not that I think of the radio as my enemy, but okay, I think we're ready to try it again. I'll put the power on, this time restricted again. Okay. And we'll watch the eye. Now definitely the B plus voltage is low. I will connect this up again with the eye. There we go. Yeah, so I'm reading 110 volts. What happened to the 130? Oh, right, I have it on current restriction right now. So I wouldn't expect the eye to glow. So we'll raise the voltage now. There we go. Raise the supply voltage. And there it is glowing. It is glowing. Maybe I'm chasing. I mean, it's visible here in the shop with moderate, kind of like dinner time type lighting to my eyes. It's visible. And now the voltage is 131, when the minimum voltage supposedly is 125. And the voltage on the back of that resistor is 5 volts, negative too. Okay. I'm quiet here because I'm not sure really what I should try next on this guy. Yeah. Well, could try applying a separate B plus. Could try lowering that resistor on the back there. It's a bit of a project to get in and change that resistor. But we might have to do that and see if that makes a difference. So I think I'm just going to go and do a little more educating of myself here before we do the next step.